Good morning to all of you. In this video we are going to see the subject engineering graphics. In that we are going to deal with the unit 2. The topic is principle of orthographic projections. Let's go to the slides. So in the first slide we are going to see the principle of orthographic projection. So in this one we are going to first of all name the components which are involved in the principle of orthographic projections. So first of all to project a thing we need an object. So the object should be in the center. Towards the one side of the object the plane of projection will be there, and to the other side the observer should be there, the viewer or observer should be there. So in orthographic projection the main thing is the observer should be right in front of the objects. Then only the visual rays which is coming from the eye of the observer will hit the projection plane in 90-degree manner. So that in orthographic projections we can, if you project an object, the object will be captured in exact true dimensions. Okay, so in this line, in this figure you can see in one side the plane of projection is there, and one side we get the, in the projection plane you get the view of the object with the true dimensions, and to the right hand side of the object the observer is standing. He should be standing right in front of the object, not in an inclined manner. He should be orthographic to the object. Okay, so that lines, visual rays coming out of that, so since it's in the front view it is a square, so there are 4 lines making up the 4 sides of the squares. These lines or imaginary lines are called as projectors. Okay, here the next slide we can see the principal orthographic views. So from the first slide we know how to project a object, or how we can create a projection of an object. Okay, so now so we are going to study about the principal orthographic views. It studies about so where we want to draw the projections, either front view or top view. So these two views will be occurred in 2 planes. So in which planes we are going to draw which view, that is what only we are going to see in this principal orthographic views. Okay, so you can see one projection planes. So one is vertical plane, and 90 degree to it there lies a horizontal plane. So in that you, from the, as you studied in your mathematics, the first quadrant lies between 0 and 90. Okay, and the second quadrant lies between 90 and 180, and the third lies between 180 and 270, and to 270 and 360 lies the fourth quadrant. So this is what we studied in maths, but here you can easily tell like that. So above HP, the first quadrant location is above HP in front of VP. The second quadrant location is above HP behind VP. The third quadrant location is below HP behind VP. The fourth quadrant location is in front of VP and below HP. So these are the locations of the all the 4 quadrants, and if you place a object in the first quadrant and you project it on the screen, so you will automatically get the, you will always get the front view on the vertical plane and top view on the horizontal plane. You keep in all the 4 quadrants an object, you will always get the front view will projected on the vertical plane and top view will be projected on the horizontal plane. And to make it into a 2-dimensional drafting, you want to rotate the horizontal plane alone 90 degree clockwise after drawing the projections. Okay, so that only is given here, the revolving direction, rotate the horizontal plane 90 degree clockwise. So that common line of intersection, that is the XY line, reference line, is lying in the in between the vertical plane and horizontal plane. That is a common reference line. So above reference line you will get the front view, and below reference line you will get the top view in case of first angle projection, which is done in the first quadrant. Okay, so remaining things, the projection of points, projection of straight lines, we can see in the next session. Thank you.